Hey guys, my name is Lydia. I'm a student at U32 High School in Vermont, and today we're going to be talking about quantum entanglement. When I first heard about this concept, I was baffled. Could this really be the way the world functions at the atomic scale? Was there perhaps something I was missing? I decided to investigate the concept further, and here's what I discovered. Quantum entanglement began its existence as a concept meant to demonstrate that quantum physics must somehow be incomplete or deficient in some way. In 1935, Albert Einstein, along with two of his research associates, Boris Podolsky and Nathan Rosen, wrote a paper which basically stated that quantum theory, if it was to be taken at face value, would allow for some seriously spooky action at a distance. The concept can be vulgarized as stating that by taking a single system and splitting it in two, a symmetry should be found to hold. Essentially, properties of one child system will be balanced by the properties of the other child system. This in and of itself is not so weird. It's like saying that if I take this cookie and I break it in two, there's a certain symmetry between the two parts. One is the exact opposite of the other, with respect to the parts of the original whole it is composed of. But quantum physics isn't really that simple. In quantum physics, a cat can be both dead and alive. Schrödinger postulated a thought experiment following the EPR paper, attempting once again to disprove the oddly reactive nature of the atomic world, introducing quantum superpositions, popularly referred to as Schrödinger's cat. This is like saying that if we took a pair of shoes and separated them by arbitrarily large distances and gave them to two different people, while both of these shoes would look like slippers, no clear left or right side, as soon as one of the two people would put the slipper-looking thing on their left or right foot, the shoe would mold itself to become an appropriate fit for the side chosen. At that exact same moment, the shoe held by the other individual across the room, or even universe, would become right or left-footed in order to ensure that it is a complete pair. This type of magical balancing of the universe is something that we sometimes attribute to things like karma or the yin-yang, but to think that the very stuff of the universe would shift around like this is, to say the least, very disturbing. In the EPR paper, it is understood that the main thing that should make this whole premise absurd is that faster-than-light communication is impossible. And so if we separate the atoms by a sufficient distance, there would be a delay proportional to the speed of light in one system's reaction to changes in its sibling system. Quantum physics, in theory, claimed there would be no delay, since such an instantaneous sending of information was held to be an impossibility. It was believed that the EPR paper once and for all put an end to all this quantum superimposed silliness. And then came 1982. Where Alan Aspect seemed to demonstrate in a simple experiment known as the Bell test experiments that entanglement was, in fact, an observable property in the universe at a very small scale within a very controlled environment. Scientists were not convinced, however, and loopholes were found in all the experiments that attempted to validate the theory. That is, until 2015, where an experiment performed in the Netherlands demonstrated entanglement in two very small diamonds at near room temperature in such a way as to close both postulated loopholes previous entanglement experiments could have been utilizing. This experiment is highly significant because not only does it force a shift in perception in favor of what seems to be a law of nature, but it also begins to bring the concept of entanglement closer to macroscopic applications for everyday use. In fact, quantum entanglement is already currently used in industry, being the key component that makes quantum computing possible. So what began as an attempt at pointing out inconsistencies of a theory by bringing the implications to its extreme conclusions instead turned into a truly groundbreaking, intriguing, and useful understanding of a fundamental property of the universe. From completely secure quantum communications to supercomputers, the possibility of quantum teleportation, I believe entanglement's potential implications and applications will continue to surprise us all.